Okay. All right. Here's a molality and molarity problem from ALEKS. I actually emailed the ALEKS people and asked them what it was in the world they were doing by asking these questions in such a poor way, because it is asked in a poor way, especially the one about molality. And so they responded to me, and I'll show you what they shared with me and the way that we can solve these. So at least ALEKS, you get it right in ALEKS, but I think the way of asking it isn't really what happens in real chemistry. So here's the question. The student dissolves 15 grams of biphenyl in 170 milliliters of a solvent with a density of 0.88 grams per milliliter. Even though this doesn't happen in real life, the student notices that the volume of the solvent does not change. That is just not a true statement, but for ALEKS to get their question asked in this way, it's just what they had to say. So the key to the molality part is to recognize that when we're doing kilograms of solvent, that this is the actual number that we're going to use. And so if you watch the other video, you'll see the way that everybody else in the world does it, but this is the way that ALEKS does it. So again, let's just remember our definitions, because that's really going to help us here. So molarity equals moles per liter, and molality, little m, molality equals moles per kilogram of solvent. Okay, so let's, since moles is common to both of these, let's quickly solve for moles. Okay, so I have 15 grams of this biphenyl. Okay, let's just convert that to moles. I know, because I looked it up on Google, that there are 154.21 grams in 1 mole of biphenyl. And when I do that math, then that gives me 0.09727. I'll take it out to that many decimal places for now. The sig figs will change that, but so there's that many moles. So when I do these equations, I'm going to put this number, 0.09727, into the numerator for molarity and for molality. So let's tackle molarity first. Remember, molarity is moles per liter. Well, it tells us essentially how many liters. It gives us to it in milliliters, but we can solve for that. So I'll just go above here and say that there are 175 milliliters of this solution, and there are 1,000 milliliters in 1 liter. My units will cancel here, and so that will give me 0.175 liters. So I'll just come down here. Molarity equals moles per liter equals, I'm going to grab this number right here, 0.09727 moles in liters is 0.175 liters, which I calculated right here, which got from the problem. And when I do that math for my molarity, I get 0.56 molar. And so I solve for molarity. So in here I'm going to write 0.56 molar. Alright, so let's solve for molality now. So molality again is moles per kilogram of solvent. It doesn't give us a mass of solvent, but it does give us this conversion factor of density. And I would rewrite that density, I'll just write it up here, that's really saying 0.88 grams are in 1 milliliter. Just easier for me to see it in a fraction rather than written in a sentence just like that. Okay, so let's get those kilograms of solvent, because that's what molality is moles per kilogram of solvent. So 175 milliliters is what I'm given. Well, based on the density, I know that in 1 milliliter there are 0.88 grams of the solvent, and my computer's just a little bit slow right now, and I know that there are 1,000 grams in 1 kilogram. So my units will cancel here. This is a true statement because I get the density from the problem here. My units again will cancel, and this is a true statement. There are 1,000 grams in 1 kilogram. So when I do that math right there, then I get 0.154 liters. So now I have that's kilograms, dummy. That's kilograms. And so I have moles right here per kilogram of solvent, which I solved for right there. So let's do molality, molality, equals moles, which is 0.09727 moles. That comes from right here. Per kilogram of solvent, which is 0.154 kilograms. And when I do that math, then I calculate there are 0.63 moles per kilogram of solvent. There is my molality right there. And so I would come up to my problem. I can get that to move back up, and I would answer that. Oh, for heaven's sakes. Let's see, hopefully I can go back here. And so if I said molality, I would write 0.63 moles per kilogram. There's molality. Alright, that's how ALEKS solves it. It's actually not a great way of doing molality, but when I talked to the ALEKS people, they actually said that it fooled them at first, just like I guess it fooled me. I think they're fools to ask the question that way. So that's how you would solve this problem. Just use moles per kilogram. Just use the volume and multiply by the density. That will get you grams, and then convert that to kilograms. So that's how you do it.